Hello everyone, and I hope that you're doing well. Today we're doing a past paper review of a BGCSE Physics paper. This is a paper 2 from the year 2022. Please remember, before you start the examination, always write the school number, your candidate number, your surname, and also your initials. Please also read through the instructions carefully, ensure that you understand each instruction, and if you should have any questions or queries, please clarify those with the examiner before the examination begins. Now let's jump to question number 1. And question number 1 reads that figure 1.1 shows two cyclists. Brian is a racing cyclist with a light bicycle frame. Andy is a mountain cyclist with a heavy bicycle frame. All right, the pictures are showing both of them. And so for the question, is that Brian and Andy have the same mass and produce the same driving force. And just to remind you that force is equal to mass times acceleration. For part A, is which cyclist would produce the greater initial acceleration if both are moving on the same surface, and that will be Brian. And the reason for that is that the lighter frame bicycle has less inertia, all right, and inertia is a resistance to motion. So heavier bicycle or heavier mass will produce more inertia. And also to note is that to produce the same force as what was explained right here, the smaller overall mass must generate a higher acceleration. And the reason for that is because mass is inversely related to acceleration. All right. And a point to note that inertia is also explained by Newton's first law of motion. All right. And so part B is that after reaching a maximum speed of 10 meters per second, Andy maintains that speed for 3 minutes. Calculate the distance that Andy has traveled during this time. And so again, as a reminder, velocity or speed is equal to distance over time. For velocity to be displacement over time. And so distance is equal to v times t. And just to point out that distance, v here is 10 meters per second. However, time is in minutes. So you have to convert that into seconds. And so it'll be 3 times 60. And so we have a total of 1,800 meters. For part C, it's a Brian and Andy decide to test ride identical bicycles on two different horizontal surfaces. So the surfaces are different. It's an Andy start sometime after Brian. It's the graph in figure 1.2 shows the velocity changes with time for both cyclists. All right, and so you could observe the graph. If you notice the slope, Brian's slope is less steep compared to Andy's slope. All right, and so let's go into the question. The first part of the question is how many seconds after Brian did Andy start? And so if you look at it right here, it is 3 seconds after. So notice the difference in the line. So it's 3 seconds. It's at what time did Brian and Andy have the same velocity? And so if I go back on the graph here, this will be the same velocity right here. And if you should match up the time with that, then that will be 5 seconds. All right, so at 5 seconds, they both have the same velocity. For part 3, it said, what does the change in the velocity of each shown in figure 1.2 tells us about the surfaces that each is riding on? And it's explained using one of Newton's law of motion. And this could be explained pretty much with all the laws. And so I choose the second law here and just remind what the second law is stating. And the second law states that the acceleration of an object is inversely related to the mass of the object and proportionally related to the net force acting on it. All right. And so to explain the difference in the surfaces based on what the question is asking you, Andy is on a smoother surface. Brian will be on a more rough surface or a rougher surface, right? All right. And so based upon the second law now, acceleration depends on the mass and the net force acting on the bicycle. Since the masses are equal because they're identical bicycles and both of them also have the same mass, then the difference in acceleration is due to the difference in the roughness or the friction of the surfaces. And so the smaller surface produces less resistance. So there's less friction. All right. And so that can also be explained by the inertia law, which is the first law of motion. Because if you have a greater inertia, then you have a greater resistance to motion. It can also be explained by the third law of motion as well. The greater the friction is, which is an opposing force, it is the slower it will go, which means less acceleration. Because the third law will state that to every action there's an equal and opposite reaction. And so the greater the resistive force is, the less the force that pushing the object forward. And so again, if force and acceleration are proportional, a decrease in force will result in a decrease in acceleration. All right, so let's go to question number 2. So the figure below shows an apple hanging from a spring balance. And so let's go to the question here. And so it's on the diagram, label the downward force acting on the apple. And so the downward force here is F, and is the weight. So you can use F or W. It didn't say use a letter, but its downward force is this arrow, the upward force is this one, and it's called a normal. All right, is a stated word used to describe the energy stored in a spring that has been stretched or compressed, and that energy here is called the elastic potential energy. So anything that is elastic or can be compressed and stretched, then yes, elastic potential energy. Part C, the apple has a mass of 100 grams. Calculate the weight of the apple. And so if we take gravity to be 10, because remember that weight is equal to mass times gravity, let me just quickly put that in. To calculate weight, weight is equal to mass times gravity. So it's equal to mg, all right? And weight is a force, as I pointed out. And so if you use 10 as gravity to be 10, then it will be 1,000 Newton. If you use gravity to be 9.8, then it will be 980 Newtons. For the rest of the calculation, I'm going to use the 9.8 for gravity. It's a stated value of the upward force exerted by the spring balance on the apple, and so it is equal to the weight, because the upward force must equal to the downward force. And so if 980 is the weight, then 980 must be the force exerted by the spring on the apple as well. Part D, mass and weight are two different quantities. It's a complete table using the correct description of each. And so on the column on the right, it says scalar or vector. Mass is a scalar because it's only a magnitude. Weight is a vector because it has both magnitude and direction. Again, weight is a force. For part E, it said the spring balance is governed by an equation linking the force acting on it and the extension of the spring. And so write the equation in the space provided. And so the equation here is force equal to Ke, where K is the constant, E is the extension, and F is the applied force. Now for part F, it said the apple above produces an extension of 6 millimeters in the spring scale when it is attached to it. Calculate the value of the spring constant in newtons per meters. And so, again, we're going to use this formula to help us out with this. But before I go to that, notice here we have meters and here we have millimeters. So I've made the units be the same. And so we're going to convert our millimeters into meters by dividing by 1,000, which gives us 0.006 meters. And so therefore now to find our constant, we're going to say force divided by extension. And so the force is 980, which is the weight, divided by 0.06. And so therefore we have here 163,333.33 newtons per meter. Or we can just say 1.63 times 10 to the 5 newtons per meters. All right, so let's go into the next question now. Question number 3. So this question is about kinetic theory and the behavior of molecules. Orange juice is gently poured onto white grape juice and floats on the white grape juice as shown in figure 3.1. All right, so the orange juice is floating on the white grape juice. As I use in the diagram, state which juice is more dense, and the white grape juice is certainly more dense because it's at the bottom. Denser substances will sink, and less dense substances tend to float. Part 2. The mixture in figure 3.1 is left untouched at room temperature for about 12 hours. It is noticed that the two juices have spread into each other. And here it says, suggest a reason for this using the word molecules or particles in your answer. And so it says, and so just for me to answer this, is since liquid particles are not totally compact, I will start out to that to give you the situation of liquids, because liquid particles are not totally compact. And so therefore the particles can move from an area of higher concentration to a lower concentration throughout each other. If there were two solids, because of how compact the particles are, then diffusion couldn't take place. So this actually diffusion of the molecules in each other. Otherwise, you'll use a term that they dissolve. And this reason also is because the liquids are miscible, which means they can pass through each other. If they're miscible liquids, like oil and water, then they cannot mix, right? And so they will stay separated. Now for part 3, It said the original mixture in figure 3.1 is placed into the refrigerator. After about 12 hours, it is noticed that the two juices have not spread into each other as much as in A2. So how does the refrigerator's cooler temperature affects the kinetic energy of the particles and their movement? And so let's look at the kinetic energy. It will decrease. All right, so the energy was decreased, and simply because higher temperature will produce more heat energy, and heat energy will be converted into kinetic energy. And so the movement of particles will be slower, and they're slower simply because they have less kinetic energy. All right. And so for part 4, it said when the cold glass containing the white grape and orange juice mixture is removed from the refrigerator, water droplets from the outside of the glass. All right. A matter of fact, I think this was supposed to read that water droplets on the outside of the glass was seen, something like that. All right. It says name the process taking place which result in the formation of water droplets on the outside of the glass. And this process is called condensation, because in the atmosphere you have gaseous water molecules. All right, you won't see them, but as they go to the glass, they become cooler, and once they become cooler, they condense and turn from gas into liquid. Now for part B, it's a similar mixture of white grape and orange juice is made another day. The orange juice, which has a mass of 90.9 grams and a density of 1.01 grams per centimeters cube, is added to 150 centimeters cube of white grape juice of density 1.16 grams per centimeters cube. Is a calculate the volume of the orange juice added to the white grape juice. And so define volume. First, let's remind you of the formula. Density is equal to mass over volume, right? So volume then is equals mass divided by density. And so therefore the volume here will be 90.9 because we want to find that of the orange juice. And the orange juice mass is 90.9 grams and the density is 1.01. And so if you divide 90.9 by 1.01, you get 90 centimeters cube. And to go to the next part of the question, we're going to calculate the mass of the white grape juice. And so again, mass is equal to density times volume. The density is 1.16 based on the question, and the volume was 150 centimeters cube. Therefore, multiply them, you get 174 grams. For part 3, you're going to calculate the density of the white grape and the orange juice mixture. State your answer to 4 significant figures. And so I kind of put this in 2 methods. And so the first method, which is the most accurate method, all right, is the density is equal to total mass over total volume. And so we find the total mass here and the total volume, which gives us 264.9 divided by 240, gives us 1.104 grams per centimeters cube. The next method is to find the average density. Adding the 2 densities divided by 2, we get 1.085 grams per centimeters cube. It's not as accurate as the first, to be honest with you. And the point to note right here, if you notice, for this, if you run this off to 2 significant figures, you get 1.1. In the same breath here, we should run this off to 2 significant figures, you get 1.1 as well, right? So both of them are pretty much the same thing. All right, but again, method 1 tends to be the most accurate one because you account for all the masses and all the volume. Now for part 4, it's to identify the type of wave marked E in figure 4.1 shown. And so you have increasing frequency going towards the right, coming from radio wave into gamma wave, and you have increasing wavelength from gamma ray into radio wave. And all these waves, they are members of the electromagnetic wave. And so the only one that is missing here is visible light. So that answer is visible light. It's the radio waves are used in communication. Identify another wave that is used in communication. And so microwave is used in satellite, so that's another option. I wanted to just notice something here, that microwave is just after radio wave, right? So it's similar, not too far in terms of frequency and not too far in terms of wavelength, all right? And so in terms of communication, microwaves can be used and they're used in satellite. Infrared can be used, but it's used in communication between a device and a remote. So the example, TV remote and a TV. Visible light can also be used, and visible light is used in fiber optics communication. All right, so for part B, wave can be longitudinal or transverse, right? It's a given difference between longitudinal wave and transverse wave. And so the two major differences between these two is that longitudinal waves, the wave particles move parallel to the propagation, while in transverse wave, the particles move perpendicular to the propagation. All right, and that's why you notice that transverse wave, you see the wave going up and down across undisturbed position. And in longitudinal wave, what we have is compression and rarefaction. And for transverse wave, we have crest and trough instead. Now for part C, it's at night, bats emit sound to detect obstacles and prey, and they do this by a process called echolocation. It's the speed of sound in air is 340 meters per second. The bat emits sound of wavelength 0.0085 meters. Calculate the frequency of the sound. And so the speed of a sound is equal to frequency times wavelength. So therefore, frequency is equal to speed divided by wavelength. All right, and so here we're going to have 340 divided by 0.0085, and so we get here 40,000 hertz. All right, for the next part of the question now, it's a laser beam strikes a plane mirror as shown in figure 4.2. What is the value of the angle of reflection? And so we must first determine the angle of incident. This is not the angle of incident, by the way. The angle of incident is right here. I could just mark it off real quick. So the angle of incident is right here. Right here is the angle of incident. And so if here is 50, then here must be 40 because it makes a 90 degrees. And so the law of reflection states that the angle of incident must equal to the angle of reflection. And if angle of incident is equal to 40, then the angle of reflection must also equal to 40 degrees. All right. Now jump into part E. It said the laser is then pointed to a concave mirror. Figure 4.3 shows the path of two parallel laser beams emitted from identical light sources. Complete the ray diagram to show the path of the laser beams after striking the concave mirror. Label the focal point F, so we're going to answer these two in one. And so the diagram will show us right here that once the rays are parallel, then they are going to reflect and they're going to converge at a point. And so here, if you notice, where they converge is actually the focal point. The focal length, we can't determine it unless they give us that or ask us to calculate it. It would be a different story, and we go through that another time. All right, so let's go into the next part of the question. It said this question is, well, there's a next question, by the way. It said this question is about energy. And it said define internal energy, not just energy, but internal energy. Energy is the ability to do work, but internal energy is the sum of the kinetic energy and potential energies of the particles in a system. All right, so account for all energy. And of course, sometimes this can be referred to as mechanical energy in a sense, right? Because mechanical energy is the total energy in terms of kinetic and potential. All right, so they are similar. Figure B, sorry, not figure B, but option B. Figure 5.1 shows energy transformations that take place in a microphone. Is a complete figure 5.1 to show the energy transformations that take place in a microphone which is connected to an amplifier. And so what is going into the microphone is sound energy. And sound energy is produced by vibration. What you get out is electrical energy that will go into the amplifier, and you also get some form of heat. All right, for part 2, I said the output power of the microphone is 100 milliwatt. And I say I make sure I like milliwatt for a purpose. And it's a calculated total energy used when the microphone is connected to the amplifier and turned on for 5 minutes. The formula that I give right here is power is equal to energy over time. And so what I want to point out, if this is in milliwatt, then you have to convert that into watt first. And so milliwatt into watt, you divide it by 1,000, you get 0.1 watt. All right. And they're going to convert minutes into seconds. And so minutes into seconds, it will be 5 times 60, give us 300 seconds. And so therefore, to calculate energy, energy now would be equal to P over T. All right. And so therefore, divide power by time, what are going to get, P times T. To find energy, it is P times T, which is power times time. And so power times time, you get 30 joules. That's how you calculate energy. All right. And so part C, here I said the table now shows the force on two identical boxes, and the direction of the motion. It's a completed table by stating whether work is done by the force shown on the object in each case. And so for option A, the force that is acting on the object is going upwards, but the motion is going towards the right. And so if it's moving towards the right, it's not because of this force, so no work is done by this force. All right? For work to be done by the force, it must go in the same direction. And so for diagram B, the force is acting upwards, the motion is also upwards, so therefore this motion is created by this force, hence this force is what is causing the work. So work is done at this point. All right, for part 2, is to calculate the work done against gravity by a 60 kg boy as he climbs up a set of stairs consisting of 10 steps, each with a height of 0.5 meters. And so, firstly, energy is equal to mass times gravity times height, because that is potential energy, and that is the energy that is due to gravity or against gravity. And so therefore, we're going to have 60 times 9.8, and for the total height, it will be 0.5 meters multiplied by the 10 steps, and so therefore get 2,940 joules. All right, so now for the next question. Question number 6. Is that thunderstorms are frequent in the Bahamas. After thunderstorm and lightning, there is an electrical discharge. There are electrical discharges. And so it said, explain how lightning is produced in the clouds using electrostatic theory. And so now what happened here now, because in the clouds you have some ice crystals and water droplets. And so the rubbing of the ice crystals and water droplets in the clouds generates static charges. The negative charges accumulate at the bottom of the clouds. When this charge is strong enough, it will be attracted to positive charges on the earth or other clouds. Due to this attraction, electrons flow rapidly, colliding with positive charges, and that create what they call light, and we know it as lightning. You also produce sound, and that sound is known as thunder, and some form of heat is also generated. All right, the point to note is that the lightning will be seen and then the thunder will be heard after. Even though both of them are generated at the same time, the reason why you see the lightning first is because light travels faster than sound. Now for part B. Is a typical lightning strike carries a voltage of 300 million volts and a current of 30,000 ampere. And that's a whole lot of voltage, by the way. That's how lightning could really kill. All right, it said if the energy in the lightning strike can be stored and then used to power light bulbs, each of 100 watt ratings, what is the minimum number of these bulbs that can be lit? And so a point to note again, or reminder, is that power is equal to current times voltage. All right, and so therefore power multiplied by volts, what we get here is 9 times 10 to the 12. And so for the number of bulbs, it's going to be the total wattage that we calculate here, which is 9 times 10 to the 12 divided by 100 for each. And so we're going to get here is 90 billion bulbs. All right, that would be awesome if we could really use the energy from lightning, but that's going to be dangerous and difficult. Now for part C, it's a 6,000 watt instant hot water heater operates for 15 minutes to heat water for taking a shower. A 3,000 watt traditional hot water heater operates for 1 hour for the same purpose. And so what I did is to convert these into kilowatts. So the watts are converted in kilowatts, and the minutes is converted into hours, because we're going to need that for calculation. Is given that the cost of electricity per kilowatt hour is $0.3, which is same thing as 30 cents. Calculate the cost to run both heaters and state which one is the cheapest. And so for the 6 kilowatt heater, you're going to have 6, which is the power in kilowatt, multiplied by hour, which is 0.25, times the cost, which is $0.3, and you get here is $0.45 or 45 cents. For the 3 kilowatt heater, that operates for 1 hour, so it's 3 times 1 times 0.3, you get 0.9 cents. Well, what is 90 cents, I should say, or $0.9. And so based on the answer, it said the 6 kilowatt hours heater will be cheaper, or cheapest one. And so if that is the cheapest one, based on the value right here, matter of fact, is half the value of the 3 kilowatt. However, point to note, if both operate for the same time, then the 3 kilowatt would be the cheaper one. Next question is that this question is about radioactivity. The radioactive isotopes carbon-14 makes up a small proportion of carbon content of living organisms. After organisms die, the proportion of carbon-14 they contain decrease due to radioactive decay. It's a scatter graph for the count rate on a nearby radioactive isotope detector against time. And so if you notice that it's declining, because what will happen over time is that half the nuclei will decay with time. All right, and so if you notice, it shows the inverse with time because it is decaying or breaking down by half the nucleus each time. But part B is a scientist at an archaeological site often estimate the age of fossils using carbon dating. The half-life of carbon-14 is 5,740 years. It's one of the bone samples at the archaeological site was analyzed. It was determined that the original is 60 grams. So that's the mass, the original mass is 60 grams of carbon-14 present in the bone. Only 7.5 grams of carbon-14 remain. It's a calculated age in years of the archaeological sample of bone. And just to make a note right here, to determine number of half-lives, what you're going to do is to break down the sample by half each time. And so 60 to 30, 30 to 15, 15 to 7.5. And so what you're going to have here now is it takes 3 half-lives to break it down to 7.5. And so the number of years will be 3 because there's 3 half-lives. And each half-life is 5,740. So therefore get 17,220 years. Here now it suggests why carbon dating is likely to be unreliable if a sample is less than 200 years old. And so the decay is very small. Just to make a note, for 200 years, it will be a very, very small decay because the half-life is 5,740. So think about it. If that decay is so small, it will be very difficult to be measured or determined. So the actual calculated, it will be really, really difficult to be measured because the decay is very, very small. So for half the sample to decay, it's going to take 5,740 years. All right, so part C, so carbon-14 decay by emitting a beta particle. What is a beta particle? And so a beta particle is a radioactive particle that emits from the nucleus of an atom, resulting in no change in mass, but an increase in proton by 1. Part 2 is after beta decay, carbon-14, and carbon-14 is given as 14 and 6. 14 is the mass number, 6 is the proton number or atomic number. State that a new element is formed. State the atomic and mass numbers of the element formed. And so the atomic number will increase by 1 because the proton number increases by 1. And so you have 7. The mass number remains the same, so it will still be 14. But part D is that some rocks in the earth contain radioactive element uranium-238. When an atom of uranium-238 decays, it gives out an alpha particle. The following statement about the alpha particle was written by a student. The statement is not correct. And so the statement reads that alpha particle can pass through a very thin sheet of lead. It's a change one word in the statement to make it correct. Write down your answer, write down your new statement and explain why. And so the first sentence is a new statement. Is the alpha particle cannot pass through a very thin sheet of lead. And the explanation for that is that alpha particles have the lowest penetrating power and can be shielded by a single sheet of paper. All right, and so that ends that question. Now we're on to our final question. Is that this question about electronics? Figure 8.1 shows a filament that has heated to 2,500 Kelvin. And point to note that this device here is what they call a vacuum diode. A diode because it has only two electrodes, which is a cathode and anode. If there was a third electrode, then this would be a triode. I said, what is the name given to the particles that leave the cathode? And the cathode is a negative electrode, just to make a note of that. So the negative electrode, and what is coming out of the cathode will be electrons, all right, because electrons are given off from the cathode. It's a state the name of the phenomenon, and the phenomenon is thermionic emission. So it is thermionic. So I just want to make this clear that therm comes from thermal, which means heat, and ionic comes from the loss or gain of electrons. So if you go back to the diagram, you're going to realize that there's a filament, and the filament here produces the heat. And once the cathode is heated enough, then you're going to release electrons. And so thermionic refers to this phenomenon that heat is required to release the electrons. All right, and again, ions is either loss or gain of electrons. So loss of electrons here, it forms an ion or is an ionic concept. So thermionic emission is the correct term. All right, and so part 3 is to explain what would happen in the circuit if the polarity of the battery was reversed. And so if you change the polarity, which means you're moving positive, negative, and negative, positive, then when the electrons leave the cathode, they will be rejected or repelled by the anode. Because again, like charges do repel. All right. Now for the next part of the question, and you can even put that part that like charges repel. So therefore the anode will repel the electron. All right, so part B. An electrical component P produces the output signal in figure 8.1 when it is connected to a power supply. And so the input current here is an AC, if you notice the motion or the wave-like motion. So this device here now will convert this into half of the signal, which you call it half-wave rectification. And what is produced here is a DC current. And so the device here, so what type of electrical component is P, and that is called a diode. And then the next part of the question said, now draw the symbol of a component P when it's placed in a circuit. And so a diode is drawn like this. The anode is the positive, the cathode is the negative side. It's a describing a type of current shown in the output signal. It's called the pulsating direct current. All right, a direct current only will just be a straight line. All right, but I'm sure if you have direct current here or just direct current, then they will give it that marker I will suspect. And I just make a note here that this is a half wave. It is not a full wave, it's a half wave. All right, and to finish up this question is a state and explain the process shown in figure 8.2. And this process is called rectification. And the explanation is that the diode causes current to flow in one direction. And so hence converting alternating current to direct current. All right, so we're at the end of this, and I wish you well in the examination. And please remember to study well and still continue to watch for other reviews. And please, if you haven't done so, please subscribe, share with your friends as well. All right, talk to you soon.